In this video, you will learn how to graph rational functions. You will be viewing the functions in the standard window. You will also see the difference between the connected and dot mode when viewing the rational functions. Before we begin, let's check to make sure we will be viewing the rational functions in the standard window. So remember, what we need to do is go to the zoom button, and then we want Z standard. That means that all graphs that we view will be shown in the standard viewing window. So we hit number 6, and here's our standard viewing window. And remember that the x-axis goes from -10 to 10, and the y-axis goes from -10 to 10 as well. In the first example, we're going to graph a rational function, which is y equals 5 divided by the quantity x minus 4. So we go to the y equal button, and this is where we input our functions. So we want to graph y equals 5 divided by the quantity x minus 4. So we need to use our grouping symbols on the function in the denominator. So we're going to use a left-hand parenthesis in the denominator, then x subtract 4, now close the parenthesis. We needed to use the grouping symbols here in the denominator because if we did not, the calculator would interpret that a completely different way. Okay, this says 5 divided by this quantity. If we left off the grouping symbols, the calculator always uses order of operations. So the way it's going to interpret this without the parentheses, it's going to take 5 divided by x and then subtract 4 from that. Okay, so it's very important that you use the grouping symbols here in the denominator. Alright, so let's go ahead and hit graph. This graph is shown in connected mode, and the connected plotting mode draws a line connecting each point calculated for the selected function. So what that means is that there's a few different points, individual points, along this curve, and you can't see them now because they're actually connected by a line between each point, and that gives us the curve. So there may be a few points here, and then there's a line connected between each point, and that gives us the curve. Now later on, we're going to view this function in dot mode, and then you'll see the actual individual points. Okay? Now, I don't want you guys to be alarmed if you're viewing this and you don't see this exact function right here, or the exact window that we're seeing. You may see a vertical line that's going down through the point x equals 4. Okay, so here's the point 1, 2, 3, 4. There's where x is equal to 4, the point on the x-axis, and there'll be a line going through that point at x equals 4, and that's the vertical asymptote. So if you have a TI-83 series calculator or an older operating system for the TI-84 series calculator, your graph will include vertical asymptotes as shown in the window to the right. Okay? Now, if you want to update your calculator, meaning updating the operating system for the TI-84, you can do that, and that will get rid of the showing of the vertical asymptotes. So for the TI-84 users seeing the vertical asymptotes, you can download the current operating system, and the vertical asymptotes will no longer show up. So refer to the TI website at www.education.ti.com and select support to find out how to update your calculator's operating system. For the TI-83 users, you can only get rid of the asymptotes by graphing the function in dot mode. And remember that later on I'm going to show you how to just change the mode to dot mode, and then you'll be able to get rid of the vertical asymptotes for those of you who have the TI-83 series calculators. Now let's go ahead and analyze the particular graph here. Now I just drew in the vertical asymptote here, and it's a vertical line that goes through the point x equals 4, so the equation of this line is actually x equals 4. Now let's go ahead and explain what's happening here. As you start to approach the value of x equals 4 from the left, okay, the curve goes down and it approaches this vertical asymptote. Now it'll never cross this vertical asymptote, it's just going to approach it. You can see that happening. As x coming from the right and approaching 4, you can see that the curve is going up and it's approaching that line there. It's never going to cross it, it's only going to approach it. And that's what's happening here at x is equal to 4. There's that vertical asymptote. Okay? Now there's also a horizontal asymptote, and the x-axis is the horizontal asymptote. So I just drew in the horizontal asymptote along the x-axis. So let's see what happens here. If you start out at the vertical asymptote and move along the curve to the left, you can see that the curve approaches the horizontal asymptote. It does not cross the horizontal asymptote, it only approaches it, which happens to be the x-axis, and the equation of that line is y equals 0. So it's going to get very close to that line, you can see that. And if we start at the vertical asymptote and now we will move to the right, okay, you can see that the curve approaches the horizontal asymptote as we move to the right. Okay, it will not cross the horizontal asymptote, it just approaches it. And that's what's going on here. So let's go to the dot mode. I want to show you now how to get rid of the asymptotes if you saw them initially. So let me go ahead and get rid of these asymptotes that I drew in, and how to go ahead and graph this function in dot mode. It's really simple. Remember that we have a mode button right here, and you click on mode. Okay, and you can see right here it says connected, so we are graphing all functions in the connected mode. So to change it to dot mode, we simply move the cursor down and then go one to the right and then hit enter. Okay, now everything's going to be shown in dot mode. So if I go ahead and hit graph, you can see the function graphed in dot mode. Now here are some of the individual points that are being plotted, and you can see that the points are getting closer and closer together, and if you move further to the left it looks like a continuous curve, but if you zoomed in on it the points would actually be separated. But anyways, this is what the dot mode looks like, and for those of you who did initially see the vertical asymptotes, they will be gone now, and your graph should look exactly like this, or your standard viewing window should look exactly like this. So you can go ahead and pause this video and try it out. Alright, so I'm going to go ahead and put the mode back into connected. So let me go back down over here and then hit enter. So now I'm in connected mode, and then if I hit graph, we're back to the connected mode. So let's go into the input window, and I'm going to get rid of this function so we can go to example number 2. So remember, to get rid of the function you just hit the clear button. Okay? The next rational function that we're going to draw is 3x minus 2 divided by x plus 1. So remember that the calculator interprets everything using the rules of order of operations. So what we need to do in this particular situation is go ahead and put grouping symbols around the function in the numerator and then grouping symbols around the function in the denominator. So let's go ahead and do that. So we're going to have 3x minus 2 and that's divided by the quantity x plus 1 and close that. Alright, so now if we go ahead and graph this function, again it's going to graph the function in connected mode. Alright, now again, if you have a TI-83 series calculator or an older operating system for the TI-84 series calculator, your graph will include the vertical asymptotes as shown in the window to the right. And on the first example, I explained in detail how to go ahead and get your calculator updated to the newer operating system if you have a TI-84 series calculator, and that will allow you to get rid of that viewing of the vertical asymptotes. Or if you have a TI-83 calculator, remember you needed to graph this in dot mode. So let's go ahead and analyze this function. So there is only one vertical asymptote and one horizontal asymptote. Okay, so let me go ahead and draw those in. Okay, I just drew in the vertical asymptote, which is right here, and that vertical asymptote is going through the point x is equal to -1, going through that point there, so the coordinate is actually -1, 0, and the equation of that line is x is equal to -1. Okay, and the horizontal asymptote I drew in here, okay, is going through the point y is equal to 3, so the coordinate here is going to be 0, 3, and the equation of that line is y is equal to 3. So let's go ahead and analyze this a little bit here. What's happening as we come from the left and we approach this vertical asymptote, you can see that the curve is approaching that vertical asymptote. Okay, if we went up a little further, we get closer and closer. As we approach the vertical asymptote from the right, you can see the curve is going and it's approaching the vertical asymptote. It's getting closer and closer here. Okay, so that's just a characteristic of our vertical asymptote. Now, what's happening with our horizontal asymptote, if you start at the vertical asymptote and move to the left along the curve, you can see that the curve approaches the horizontal asymptote. If you start at the vertical asymptote and move to the right, so if you're moving to the right along the curve, you can see that the curve approaches the horizontal asymptote. Alright, so that's what's happening here. Now, remember, you're not going to see these vertical and horizontal asymptotes, but you'll learn in your math class that there are particular characteristics of the function and what happens when they do approach the asymptotes, and you'll also know how to find the vertical and horizontal asymptotes. So I'm not really getting into the instruction of how to find them. I'm just showing you basically how to use the calculator and a little bit what's going on with the graph here. Alright, so let's go ahead and clear the horizontal and vertical asymptotes. And now let's clear the function out of here. So we go ahead and hit y equals. And let's clear the function by hitting clear. And then we're going to go to example number 3. Example number 3 says to take 25 and divide that by 8x squared minus 15. So we're going to input this into our y1, so that's 25 divided by, remember to keep order of operations in mind, So we're going to need grouping symbols in the denominator. So we'll start out with a left-hand parenthesis with 8x squared minus 15. Alright, and if we didn't use those parentheses in the function in the denominator, the calculator would look at that as 25 divided by 8x squared, and then that's subtracted by 15. So again, be very careful about how you input these functions. Okay? As I mentioned before, if you have a TI-83 series calculator or an older operating system for the TI-84 calculator, your graph will include the vertical asymptotes as shown in the window to the right. So if I hit graph, okay, this is what it should look like, and then you can see there are no asymptotes showing. So let's go ahead and take a look at what's happening here. This is an interesting graph. We actually have two vertical asymptotes in this particular graph and one horizontal. So where are they? Well, let me go ahead and draw them in. Okay, you can see now that we have our two vertical asymptotes, one here and one here. So the equation of this vertical asymptote is approximately x equals 1.4. And the equation of this vertical asymptote is x equals approximately negative 1.4. And this horizontal asymptote is actually the x-axis, and the equation of that line is y equals 0. So let's just go ahead and analyze this graph quickly. Now, as we approach the first vertical asymptote from the left, you can see that this curve goes up and it approaches this vertical asymptote. It's rising and it's getting close to it. Okay? And the same thing that's happening over here, okay, in this part of the curve, if we're approaching the vertical asymptote from the right, this curve goes up and it gets closer and closer to that vertical asymptote. It looks like here that it touches it, but it does not. Let's go ahead and look at what's going on between the vertical asymptotes, and we can see that as let's say we go from the origin and approach this vertical asymptote, the function goes down and it approaches that vertical asymptote. And if we start at the origin and move to the right and go to that vertical asymptote, the function also goes down and approaches that vertical asymptote. Now, as we go from this vertical asymptote, okay, x equal 1.4, and we move to the right, you can see that the curve goes down and it's approaching the x-axis. If we start at this vertical asymptote, x equal negative 1.4, and if we move to the left, this curve goes down and it approaches the x-axis. Okay? So that was example number 3. Let's go to the last example, and this is kind of a special case here that we'll talk about. And let me make a note before we do go on. There may also be slanted asymptotes that occur when graphing rational functions, and they will not be shown on the TI-83 or 84 series calculators. In fact, they were never shown on any of these calculators. Also, when graphing rational functions, there is a possibility that there could be a hole in the graph, and the hole is not shown on the TI-83 or 84 series calculators, and in fact they never were shown. So what I'm going to concentrate on now is graphing a function that has a hole in it. And the reason why I'm mentioning this, and we'll do an example, is because you don't want to rely on the graph all the time, because it may give you an inaccurate interpretation. The slanted asymptote situation, you might be able to see how the curve is actually going or the function is going and kind of figure out that there is a slanted asymptote somewhere, but for the situations where you have a rational function where there's going to be a hole in the function, you won't be able to figure that out. You really need to look at it, quote, mathematically and know that there will be a hole in the graph. So I'm going to cover that particular situation. So let me go ahead and undo our drawings here. Let's go back into the input window. Let's clear that function out. So now example number 4, we're going to graph y equals x squared plus x divided by 2x plus 2. Alright, so let's go ahead and graph x squared plus x, and that's divided by 2x plus 2. Okay, and again, notice that I put grouping symbols around the expression in the numerator and grouping symbols around the expression in the denominator. It's very important that you do that. Okay. Now, when you factor the function as shown to the right, you can see the factors of x plus 1 in the numerator and denominator. The factor in the denominator tells us that x cannot equal to -1, so there should be a hole in the graph at x equals -1. The y value will be determined after the next step. So the factors of x plus 1 cancel out as shown, so we are left with the linear function of y equals x divided by 2. So we know that the hole occurs at a value of x being -1. And when we substitute that value, -1, into the reduced function, which is y equals x over 2, we get -1 divided by 2, which is -1/2. So there is going to be a hole at the coordinate of -1, -1/2. Let's go ahead and graph this. Now, we're not going to see that hole. The only thing that we're going to see is this linear function. But we said that there's going to be a hole right around in this area. In fact, to be exact, it's going to be at -1, -1/2. It'll be about right there. So the actual graph of y equals x squared plus x divided by 2x plus 2 is shown to the right. So again, I just wanted to emphasize that there are some limitations to these calculators, and you want to really make sure that you understand about vertical asymptotes, horizontal asymptotes, slanted asymptotes, and holes that occur when you graph rational functions. So this concludes the video on graphing rational functions.